also recording this. And I'm very glad to hear that some of you were telling me already that you find this helpful, and some of the things are a lot clearer than before, and I was very glad to hear that. Please understand, it isn't really possible for me to go through 10, 11 weeks material in 3 weeks. I never thought that would be possible. If I try to do that, I think it's going to end up doing harm to everyone. Okay. So what I am doing is to try to pick out selectively what I think are the most important topics. And I've been also thinking a lot about what is the best way actually to help you guys with the remaining time. Possibly just today and Sunday. Okay. Now I know that I said we scheduled a class for next week. I don't know if there's a lot of meaning to do that. I can if you like. I don't have a problem. Okay. It's just that you might want to just revise at the comfort of your home. Okay. So what I likely will do is I'll see if I can set up some kind of online web conference, which I have done with some of you before. Either that, or I will just record all the responses of questions that you have raised, which I think is also a good idea. Okay, I'm a firm believer that we only learn by exploring questions and tossing and turning it back and forth, instead of just going over the notes or textbook cover to cover. I don't find that the most effective way of learning. Now, so here I've just as a reminder, give you an idea of what we have covered for the first session, so you know that. The second session, that was on Sunday. Okay. Now we finished with, I think I showed you a few slides regarding some rules that can help you tackle problems. So today I'm going to look at some of those problems. I really want to, and you will see when you hear me talk and explain how to do these questions. You will see that they are very closely related to the rules that I have outlined. Okay, so much so that you don't have to memorize. Again, you don't have to memorize the rules. Oops. You just have to understand why things are the way they are. Okay. You know what I'm doing? Pen is not working. Okay. You get what I'm saying? No? How about that? Okay. That's if you could do that, I would consider myself to have done something to help you. Okay. Now today, like I said, I'm gonna just quickly go back to those rules. I do want to have a look at question set number 1. Maybe not every question. I'll try and do as much as we can. Now, so today we are in CYT 410. Now this Sunday we are in the same room as last Sunday. Okay. Next week, like I said, let's see how we go. I don't see a lot of point meeting a day before the exam. Let's just take it from here. Okay. Now this is where I left off last time. So in trying to deal with delta and gamma and vega. So these are all the key members of the Greek family. There is theta as well. Theta is an easy one. What happens to delta or gamma or vega when you are long or short, or when a market is changing? So these are the simple rules. For example, when in the money, the delta of a short-term option is greater than the delta of a long-term option. Like I said, memory is not required. Just to give you an example how this comes about. So what I'm saying is when in the money, the delta of a short-term option is greater than the delta of a long-term option. But when it's out of the money, the delta of a short-term option is less than the delta of a long-term option. Now, like I said, okay, how am I supposed to remember that? And if you just memorize without knowing why, there's a huge risk that you will remember the wrong thing. And in any case, if you memorize it like that and you cannot relate to it, okay, chances are 3 days after the exam, you've already forgotten it. Okay? Now, so let me try to, just as an example, okay, how does that come about? How do I try to remember stuff like that? So when in the money, the delta of a short-term option is greater than the delta of a long-term option. When out of the money, the delta of a short-term option is smaller than the delta of a long-term option. Now, first of all, what is delta? Now, if you have a call option, okay, wow, that's pretty good, isn't it? You don't know how hard it is for me to draw. So this is a call option. This is a call option. Now, first of all, what is delta? Okay, delta is now. So here and beyond, everything is in the money, correct? Yeah. So over there, it's out of the money, and here it's at the money. Okay. Now there is another sort of unofficial term, by the way, that traders sometimes use when you are hovering around this area. Let's say plus or minus 3%, okay, of the strike. We call it near the money, okay, but that's just for your interest, okay. Near the money, okay. So near the strike, okay. Now, what? First of all, what is delta? Delta is this. Let's say you are here at this point, okay. Now, delta is nothing more than trying to draw a tangent, okay, and the delta here, now I call this, let's say, delta long term, or at least longer term, okay, delta long term is nothing more than the slope of this tangent. You all know that, right? And likewise, when you're over here, so if a call is out of the money, so you draw a tangent. Don't like that one. Okay, man. I'm going to do something which is even harder in a moment. Okay, now this is the delta of an option which is out of the money. So like I said, this is just the slope of the tangent. Now, what I'm going to do now is I'm going to draw in a different color. What happens when if nothing changes, but time passes by. So let's say you started with a 3-month option and it's now become a 1-month option. Now what happens then? First of all, your payoff might look something like this. Okay, so this is a option. Well, this is the short term. Okay. Now, the point to think about is as follows. So now, if nothing changes, then your option value is here, and your delta would be this one. Now, I on purpose, it's a little bit exaggerated, but the delta of your short-term or shorter-term option is the slope of this new tangent, correct? Yeah? Now, you can see just by visually inspecting it that the slope has increased. You can see that, can't you? And just a little bit of visual imagination would tell you that the line is gradually approaching the line here until you get to maturity date. Then the delta would just be 1 when it's actually hugging this line. Can you see that? You know what I'm saying? Okay. Now that is the reason, because if nothing changes, then your slope or your delta tangent will keep moving this way. Now, for the other, what about the other one? Okay, now the other one, the opposite is happening. Because, I know I haven't drawn it very well, but this is without ruler, standing up with a screen at 74 degrees, so it's a bit hard. But you can see that now this one becomes flatter, okay? So here, it's kind of flattening. But here, you can see it's steepening, can't you? Steepening. So if you understand what I've said so far now, I don't have a single number. It's just a diagram, okay? But I think that explains already these 2 lines that I have put there about the delta of options that are in the money or out of the money, okay? Now, you can apply the same logic for put options, except that the signs are the other way around, because put options start with a negative delta, okay? Just to recap, when there's a positive delta, it means when you are long delta, okay? When you are long delta, it means what? When market goes up, you are happy, okay? And if you are short delta, then when market goes down, you are happy, okay? Everyone is okay with that? Yeah? Do you want to ask me anything or want me to clarify? Sorry.
Why market goes up again to long delta?
Why market goes up?
Again, to what kind of mechanism that I can gain from the long delta?
Okay. Why is it that when market goes up, I can gain from long delta? No, it's more the other way around. It's more. Okay, so first of all, you have to understand what it means when you are running an option book. So you have these parameters like deltas and gammas and vegas and thetas, okay? And you can either be long or short, or you can be neutral, okay? Now, I think you need to look at it the other way around. Okay, the other way around means what is my position? So a lot of news happening on the political front. So if I call up our old friend optionprice.com, okay, and now this is pricing a very simple option. Now you can see that here I just priced a one month option with spot at 100 and exercise price 100. Now before even doing anything else, okay, you can see that the call option has a price and a delta and a gamma and vega and theta, okay? And as far as delta is concerned, you can see that delta is positive. Can you see that? 0.53. Whereas put option, the delta is negative, okay? Now that is if you buy these options, okay? So if I buy a call, I have a long delta position. And if I buy a put, I have a short delta position. Okay. If you have a short delta, it doesn't mean that you have to be short something. Being short delta and being short an option are different things. Okay. So if you have a long or positive delta, if you like, if you have a positive delta, so take the call option here. Okay. That must mean that when market goes up, you have a gain. Okay. Now, if you have a call option, that is exactly what happens. So the delta parameter is just a representation of what kind of risk you are running. Okay. Have I answered your question? Yeah. So it's actually just a matter of definition. Okay. So if you have a short delta minus 0.467, that means when markets go down, you stand to gain, okay? Which is what happens when you are long a put option, okay? So in other words, you can look at it like that, okay? So you can have call options and put options, and you can be long, you can be short, and if you are long a call option, as you saw just now, of course, you are long delta. Okay. Now, like I said, or your book, if it only has a call option and nothing else, it would have a positive delta. Now, with just that one cell, I can actually populate all the other ones without thinking because they will be the opposite. Oops, sorry. This should be minus. Okay. Now, let me just populate them and then explain what's going on. Okay. So if you long a call, then if market goes up, you're happy about that. So that must mean if you are short a call, then if market goes up, you are not happy. In that case, you must have a short delta position. Short delta means you want the market to go down, okay? Or your option book is such that if markets go down, then you have a gain. Okay? Likewise, if you long a put, what do you want to see happen? Complete disaster for complete catastrophe. So you have a short delta, and you want markets to go down. Okay. And if you are short a put, you also have a long delta, because if you sold a put, implicitly you want the markets to go up. Is everyone okay with that? Yeah? Okay, that's good. Now, so the last line there, if you can visualize the reason, you do not need to memorize. And ladies and gentlemen, I was trying to demonstrate precisely that point just now, okay? Now, let me just go to so the next page you already saw. So there's delta and gamma and vega and theta as well. Okay. Now, I told you that last time it is possible to relate the the risk neutral pricing formula for a delta hedged portfolio of an option or a derivative together with a stock, and a very small change in value of that portfolio is equal to the time decay minus a half gamma sigma square O square. So if we assume that you cannot make any profit or any abnormal profit just by simply buying or selling an option and delta hedging it, and you shouldn't be able to, okay, because otherwise there is something wrong and you can make money from nothing because you have no market risk. So this is saying that ordinarily delta pi should be equal to 0, in which case so you come to the conclusion that the time decay should really be equal to the sort of expected gamma revenue. Okay, now the actual gamma revenue, as you must know very well by now, the actual gamma revenue is a half gamma ds squared. Okay, now that is to say, if and when ds is actually equal to sigma s, so if this ds squared here is equal to the sigma square s squared here, okay, or if ds was equal to the sigma s, then our assumption will actually come true. Okay, and actually a lot of questions that are in the question sets are based on this very simple but very, very important observation. I would say of everything that you end up learning in this course, this is probably the most fundamental item that you need to, again, not memorize, but understand and appreciate. Okay? So we're going to see that coming back again and again. Now, for those of you who may be sort of intellectually curious, so like I said, if you go to the textbook of How, I would just draw, for those of you who are mathematically adventurous, I would draw you to exactly the section where this is all laid out, which I think is chapter 14. Okay, so how the hell do I do that? Okay, chapter 14. Where am I up to now? 20, too far. Yeah, how do you do that? I know this is a very dumb way. I want to locate chapter 14.
No, not here. Quartz and 14.
Okay, thank you so much. Yeah, so she's good at this stuff. Me, I just buy this and use it. All right. Now, chapter 14 is regarding the Black-Scholes model, now commonly known as the Black-Scholes-Merton model. If you can appreciate the difference and why suddenly they inserted the name Merton in there, okay, people will be impressed, because he independently also arrived at the derivation in 1973. Now, if you know a little bit about Ito's lemma, okay, so someone is smiling. All right, how do you explain Ito's lemma in a simple way? Now, you know that my favorite way of thinking about option pricing is, let's say the x-axis is time, and the y-axis is price. Let's take, it doesn't matter, stock price, price of an index. So it's sort of going up and down, minding its own business. So you're now here, okay, and I ask you to price an option. So this is the time t equals to 0. I ask you to price an option for t equals to 1, and the strike of the option is somewhere here at x. Okay. Now, actually, you just need two things. First of all, you need to ask yourself, well, at t1, okay, what is the actual forward? So first, you need to establish the forward. Now that you can do, as you know, forward or future. So that price is very simple. Okay. So first of all, you need to know what is the arbitrage-free forward price. And then the second thing you need is you need to put a distribution around it. Okay, now again, you see that a lot of the time when I explain something to you, I don't use any numbers. So you need to put a distribution. If something was extremely volatile, you might put something like this. And if something is not so volatile, the distribution might look something like that. Okay, and from that, so this is a high sigma. This one might be lower. Okay, and of course there's a whole school of literature regarding whether that distribution should be is even normally distributed. Are there skews and kurtosis and all that? It's referring to that. Okay, now and then what happens is, okay, this is the strike. Then if that was the case, then all the outcomes in the shaded area will be valuable. And the reason you pay more for more volatile stocks or any underlying is that when it's more volatile, then it has a chance of reaching the sky. And if there are more outcomes going north, then of course I'm going to charge you more. Okay. Now, this is actually quite useful. Now, this is characterizing the how a random variable might behave. And if you come down here to, I think it's 14.6 or something like that. The idea underlying the Black-Scholes-Merton differential equation. Okay. Now, this equation here if it looks a little bit scary, it is nothing more than the mathematical representation of what I just showed you. Okay. So the random process of a stock or bond or currency or commodity, anything, okay, is just the expected forward price plus some kind of random distribution. Okay. So you can actually try to model the random process of a stock. Now, the contribution of Ito's lemma is, so Ito's, originally I think it wasn't even used for finance, but it just so happens they found an application. So people are asking, Ito lemma says, if I can characterize something as a random process here, okay, sometimes called the Ito process, then if there is something else which depends on the movement of S, how can I characterize that process and that something else happens to be a derivative. Okay, now whether it's a call or a put or a futures contract, whatever, okay, the payoff depends on what happens to S. And Ito's lemma says, well, if you can actually characterize S this way, you actually can characterize any derivative process in a similar manner. What do I mean a similar manner? Well, there is something here multiplied by a change in time term, and there is something here multiplied by the distribution or the random term. Now, to cut a long story short, if you have a portfolio with an option, and then you delta hedge it, which is what they are saying to you here, and then you do some rearrangements, the value of your portfolio is this, and then the change in the value of that portfolio is this, and then you come to this one, which is exactly the equation that I showed you. Okay? So I don't want you to say, oh, Sam just told me this, so I'll just take it as given. No. Okay? There is a theoretical basis to it. Okay? Now, I want to just quickly. Is everyone okay with that? With what I just said? Okay. If not, you can go home and if you listen to it again, I think you should get it. Now, I want to just quickly recap on some of the Greeks, and here I also include rho. Have you talked about rho in class? Yeah?
Yes.
Do you understand that? Do you understand the definition, first of all?
Yes.
What's the definition?
It's when interest changes the value of the future.
So rho for options is a little bit like you know duration, right? Bond duration. Bond duration is thank you. Yeah. If you have a 10-year bond and I asked you what is the duration for a 10-year bond, which is normally approximately between 7 or 8. Okay. Now what does that mean? That means if interest rates were to change by 1%, 1% is a lot. Let's say 1 basis point. Okay. The price of the bond should change by about 7 basis points. Okay. So that's the bond price sensitivity to interest rate. Now, rho is the equivalent in the options world. The rho measures how the price of an option will change when interest rates are changing. Okay? Now, you see a lot of these Greeks here, delta, gamma, theta, vega, rho, they're all there. So these are all the members of the crazy Greek family. Okay? And if you were to derive them, which I won't, but all that happens is if you just take the so there must be a formula somewhere. Okay, here. Okay, so these are the classic award-winning, and I really mean that, they got a Nobel Prize for it. Okay, it's a classic award-winning option pricing formulas that have been around since 1973. Now, all those things, delta, gamma, vega, theta, and rho, all that's happening is, let's just take delta, okay? For the delta for the call, you just differentiate the call price with respect to S. That's all it is, okay? Now, I don't ask you to do that. I just ask you to relate what I just said to what you see here, the formula, okay? So likewise for gamma, you differentiate the price with respect to, sorry, differentiate the option price, let's say C, okay, we stick to C for call price, with respect to the stock price two times, okay, so D2C by ds squared. Now theta would just be dc by dt. So you take this formula here, either this one or this one, okay? So if you know a little bit of calculus, you differentiate that with respect to t, and maybe you ask me, oh, how do I do that? Well, the result is right in front of you, okay? Now rho is when you differentiate the option price with respect to what? Which little letter? It's when you differentiate call or put, okay, with respect to little r, okay, because that's the interest rate. So I jumped a step. I'm just showing you this formula, and then I'm saying to you that if you differentiate this or the put, okay, with respect to little r, you will get to. So I'm skipping a step. I'm just telling you what you should do, and the result is right here. Okay? Now, are you okay so far? Okay. So rho is, you can see it's equal to kt e to the minus rt nd1. I think that's nd1. Let's try and blow it up for your benefit. And then, nd2, sorry, nd2. And the rho for a put option is minus kt, and then discounted value of n to the minus d2. Now, are you still with me so far? Yeah? So all I've done is I explained to you what rho is, differentiating the call price with regard to R, interest rates, and then I tell you, okay, these are the results. I skip all the detailed calculus in the middle, okay? And then I'm explaining to you what these things are. Now K here, sorry, I kept using X as the strike, but K here represents the strike, okay? And ND2 is actually the measure from the probability density function. Now, if you're wondering, so what does ND something? What does it mean? Okay. So NDX. Okay, I put the X in there. So all that means is that you have a normal distribution, and you know how you can work out X is the what they call the Z statistic. So if this is the mean, okay, and X is here, so NDX actually refers to the area, which is here. Now this is just normal statistics and probabilities. You do know that notation, right? So ND something something something, okay, means anything which is less than X. So the probability of getting this one, in other words, okay. Now here is when it starts to get very interesting. The one thing I like about option is, if you hadn't realized that by now, when you are dealing with stocks or bonds or currencies, commodities, mostly things are linear. and even if they are not entirely straight line linear, okay, like in the case of an option, it's a little bit of a curve. It's still what I call, directional and symmetric. Here you have, I think, some of the most interesting examples in finance where the behavior of certain instruments are definitely not symmetric. Okay? Now let's take the call option, the call row to start with. That is the diagram on the top right-hand corner. You are all aware of that, right? So what that is saying is, imagine there's a stock, okay? There's a stock, and the price of the stock, okay? The price of the stock right now is 50, okay? Now that doesn't change, okay? Just stick with that. So let's say we have a stock, the price is 50, the price doesn't change, time doesn't change, well, actually holding everything constant, okay? So what we are saying with this graph is if we have a stock at 50, at this moment in time, no change to volatility, no change to the price, and if you have a whole load of options ranging from a strike of 10 to 20 to 30 to 40, 50, 60, 70, 80, 90. So if you have a whole lot of options with different strikes, given the same spot price, they will have a different sensitivity to interest rates. Are you with me so far? Yeah? So you've got to be clear in your mind what you are holding constant and what you are trying to change, okay? So you are holding everything constant except you are moving the strike up and down, and you are asking yourself, when I do that, how do the option prices of all these, let's say from 10 to 90, so let's say we have an option for every dollar, okay? So strike 10, strike 11, strike 12, all the way, okay? So how do the interest rate sensitivity of all these option prices change if I just play around with the strike? Okay? Is that okay so far? Now, I'm not saying that you price an option and then you change the strike. Of course, you can't do that. Once you've traded an option, that's it, okay? But this is just comparing a cross-sectional comparison of the interest rate sensitivity of different options where the only difference is the strike price. Okay. In other words, if you were to look at our old friend, okay, what does that mean? That means if the underlying price is 100 and your exercise was 100, now you see there's a row here, yes? 0.041. So all I'm doing is I'm saying, all right, well, let me change this to 99, okay? The strike price. And you can see that your row will change from 0.041 to 0.045. And you're saying, okay, let me write down this value, okay? And let me now go down to 98. And I'll calculate. And I'll write down this value. And so on. Okay? Now, so the end result is that here, for the call, you have a curve that goes up and then rapidly comes back down. And for the put option, the first thing you should notice about the row of the put is that it is always under the water. It's always negative. You can see that, right? And it's always negative because there is a negative sign in front. It's minus KT, and because the ND2 or even ND minus 2, okay, which I'll explain in a moment, even if it's very, very small, it can never be negative. Okay, it can be zero. So that is so first observation. The rho of a put is always negative. Okay. That just means that all things being equal, okay? Now, to put a more sort of down-to-earth English language interpretation to it, what that is saying is for coal prices, when interest rates go up, coal prices generally go up. Because because this curve here, all of it is positive. All of it is positive. Whoops, sorry. Whereas for this one, all of it is negative. Okay, so for put options, when interest rates go up, put option prices will generally go down. Now that much we can tell just by looking at this. Now as to why is it that the curve looks so funny, okay? Now you can actually trace that by looking carefully at this term and this term. Okay? Now for the call, so this is you ask yourself, okay, what happens when the strike, when K increases? Okay, now when K increases, as you can see here, there's a K here. So as K goes up, your rho should actually go up because the K is increasing. It is true, okay? That is why you have this part here. Now, why does it suddenly turn when you get to like near the money? And the reason is as follows, okay? Because when you get to around near the money, within this ND2 term, which is this term here, okay, there is also a K. You can see that, right? And at the very beginning, and then how is this K going to influence the overall pattern? Now, it is as follows. Now, as K goes up, D2 will go down. You can see that because D2 is defined as the log of, you don't have to even look at all the other stuff, just look at K, okay? As K gets bigger, then this term here gets smaller, so D2 gets smaller, and as a result, ND2 also gets smaller, okay? And so you have actually got two forces opposing each other. First is the raw K itself here, always working hard, going in this direction. But like I said, when K starts to rise, D2 goes down, and this actually, D2 goes down very, very rapidly. And so does ND2, okay? So when that sort of overwhelms, overcomes the influence of K, the whole thing actually turns and goes the other way. Are you okay with what I just said? Yeah? It's not hard. You just look at what is driving this rho parameter. Well, there's a K here, and then after this one, let me just rub all that stuff off, okay? This term looks pretty harmless, except that you got to say to yourself, well, hold on a second. In ND2, there's a little K here hiding here. And as K goes up, D2 will go down. And as D2 goes down, so that means whatever you have here, I'll just rub off the X, let's say D2. So D2 is going this way. Then of course, your ND2 is getting smaller because this area will be shrinking, and shrinking very fast. In fact, shrinking faster than your linear increase in K, okay? So that's why it turns, okay? I find that fascinating, I really do, okay? If you are a trader and you are running an option book and you have billions of dollars hanging on, and then they are about to make adjustments to monetary policy, okay? Ladies and gentlemen, this is not a joke, okay? It's real money, it's real risk in real time, okay? Now, for the put, actually, it's a lot simpler. Now, first of all, the put row will always be negative because there's a negative sign in front, okay? Now, so that much you know, okay? So it's always heading south, and if you leave this T, which is static, okay, just leave that behind for a moment. So as K increases, your put row will start to go south. Now, as K increases, like I said, D2 will be heading. D2 will be getting smaller. Okay. Now, how is the okay? Okay, let's see. Okay, I want to try and stay on this page. Now, let's say in the first instance, so K is equal to 10, okay? And then you have a D2 there, okay? Now, notice here, it's actually minus D2, okay? So what you need to do actually is to take it to the other side, okay? It's minus D2. Now, so D2 might well be, let's put some numbers to it. That way it's easier for you to understand, okay? So let's say D2 was 1.2, okay? So that means minus D2 will be minus 1.2, okay? Now just bear with me. In a few minutes, this will all become clear to you. So minus D2 of 1.2 maybe, let's say here, okay? So this is minus 1.2. Now, what happens if you suddenly increase the strike for the put option? Let's say the strike is now 20. Now, like I said, so D2 will go down, okay? So let's say D2 is now 0.8. Now, here is when you have to flip your mind. So minus D2 will be minus 0.8. It's actually going in that direction. It's going to the right-hand side because it's less negative. Are you with me? Okay. So as a result, N minus D2 also goes up. Okay. So that is the conclusion we come to. So when K goes up, D2 goes down. N D2 goes down, but N minus D2 goes up. So now you have a different situation where just ignore the negative sign for a moment, okay? So as K goes up, rho should go up, and this thing here, N minus D2 also goes up, but because it's negative, you turn the whole thing upside down, so therefore all the way it's going one way down south. You understand? Timon, yes. If you don't understand, give me a shout. Yes?
Yeah, what I don't understand, how is this related to interest rate change? I mean, we are only changing the strike price. I don't see where the interest rate influences.
Okay. You need to take one step back. How is it related to interest rates? Because it looks like interest rates are not involved. Well, actually they are. First of all, there's a little r. There's a little r in here. Okay, so he is saying, how can the option, how can the options, how can the price sensitivity of an option be affected by its strike? That's your question, right? More or less. Okay. Now, what I'm saying, okay, I think this, if you just look at a chart, sometimes it's easy to get confused. Let me just take this graph. Now, first of all, where did this formula come from to begin with? Okay, this formula came from when you take the actual Black-Scholes formula for call price or put price, and if you differentiate this formula here with respect to little r. Okay, so that much you can understand. Okay, and then so you get this formula. And it looks like that at any given strike, let's say strike 50, okay, I can calculate the row of that option by simply plugging in this formula. So let's really try to do that. So the spot price is 50, okay, spot price is 50, and if I have an option where the strike is 50, then the row would be approximately 1.2. That is what I'm saying. Now, if someone then asked you, well, if the spot price doesn't change, but now I have a different option, okay? The difference is now I have an option where the strike is 30, okay? Tell me what the row is. And then you come around here and say, okay, I can look it up. So spot price doesn't change, spot price is 50, okay? But now the strike is 30. So I will now be able to tell you that the row should be somewhere around 1350, let's say, somewhere here, okay? Now, so this graph, all it is doing is plotting all these options up and down from the strike of 10 to the strike of 90, in order to show you how, with all these 80 different options, how the interest rate sensitivity can change. Are you with me? Yeah? I am not saying that if I trade an option with you and the strike was 50, okay, then next moment I change that strike to 40. We can't do that, of course, okay? We're talking different options completely, okay? Are you okay? Yeah. And then what I've done is I proceeded to try to explain why the graphs are the way they are. If you don't get that just now, okay, I hope that is why I'm recording this whole thing. Okay. So when you go home and when you listen to it, I hope it will come to you. Okay. Essentially, it has to do with these two parameters: k, the naked k itself, and the little k hiding within D2 or ND2, okay, which actually takes over when an option becomes either deep in the money or deep out of the money. Deep in the money in the case of the put, and deep out of the money in the case of the call. When ND2 will fall, but here ND2 will, or N minus D2 will rise, okay? I guarantee you, it isn't actually that hard. If you, I think if you listen to the video again, play it at half speed if you need to, okay? And then it will come to you. All right. Now, I actually here have got some notes summarizing what I just told you in the last 20 minutes, which you can read. When we come back, let's say in 5 minutes, I will tell you a little bit about early exercise. So the plan is I will tell you a little bit about this, and then I really want to go through the questions today. And then on Sunday, what I like to do is go through more questions and then continue to talk about early exercise, okay, and then maybe try to summarize on the course. Okay. Now, why don't we try to break for 5 minutes or so? Okay, so So we are now going into the second half, and I want to just very quickly touch base with you regarding what we said earlier on. Good call, parity, Timon. So this was something I mentioned, I think, in the first session, that C minus P is equal to F minus X, except that the F there, it is not it is not actually the forward price. You call it what you want. You call it it's not the forward. It's equal to the spot price plus interest on the strike minus X, and where there is a dividend involved, as someone was asking in the first session, then you just insert the dividend. In the end, it's a funding argument more than anything else. What is your net funding cost? Okay, so this is the formula. I guess this is it's in big letters in bold, so that tells you that you probably need to know this for this course. Okay. Now this actually I can take it one step further, and so when we're talking about options, and if you're talking about European options, of course you can't exercise them early, so they are relatively simpler. But in the case of American options, which would allow you to exercise early, then things actually get interesting. Okay, so you are so always keep in mind this formula here, and for American options, the interesting thing is sometimes when an option is deeply in the money, then you don't even need to calculate in a Black-Scholes manner what the call or the put price might be, because you know that the moment you exercise that option, the theoretical price becomes the real price, which is the intrinsic value. If an option has a strike of 80, if a call option has a strike of 80 and the spot price is now 100, now if I ask you how much is the call worth, well, if it's a European call, you say, oh, this is not interesting, okay, let me price it, and you plug in all the parameters, okay. But if it's an American option, it may be possible for you to exercise that option right away, and then there is no calculation. The price is simple, $20. Okay, and it's actually flipping between to exercise or not to exercise. Okay, which makes this part of the course quite fascinating. Okay, now. I think the argument here is that, so I'm still quoting the same formula without the dividend, and so the call price should be equal to the spot price plus the interest on the strike minus the strike itself plus the put price. And the moment that doesn't hold, is when we start thinking, okay, is there something I can do about this? Okay, and if you look at lecture 7, they go into far more detail with a couple of examples, and that's the best way to go about this. Now, let's look like this. In my experience, in lecture 7, so round about page 9 is when students will start to wonder what is going on. Okay, now the thing here, let me just remind you. Okay, so lecture 7. Let me just quickly take you there. So lecture 7. This is when we start talking about early exercise and European versus American style. Okay, and then you start talking about there's an option here where the intrinsic value of a European style call option when it's $20 in the money. Of course, you have to discount that $20 back to today. But if it's an American option, you really can exercise today. So that intrinsic becomes the immediately realizable profit of $20. And should you do it? Should you really do that? And here I think is when students start to get a bit confused. So there's for example, this is page 10. So the share price is $100, so it's $20 in the money for the call. There is a dividend coming within the next 3 months, and there's also an interest rate. And there's a put price of $1 for the 80 strike put, which is quite deeply out of the money. Now, should you actually exercise the call? I have actually asked this question before to classes of previous year, and I remember one time there was a student who said, well, it depends on my view on the market. Okay, I nearly had a heart attack when he said that. Okay, it has nothing, okay, absolutely nothing to do with your view on the market. Okay, it is purely an arbitrage argument based on rational exercise, and I will show you in a moment what I mean by that. Now, the way to think about this is if as I said, you can see that now I'm just rearranging all these terms. So the call price is equal to, or should be equal to, the strike price. Sorry, I keep saying that. The spot price plus interest on the strike minus dividend plus put minus the strike. This is just rearranging these terms on the previous page. Okay, so the call is now all by itself. And then the key to this is if you exercise it the value of the call is very simply just the intrinsic value of the spot price minus the strike. That $20 you saw, okay? So the whole argument of whether you should exercise or not boils down to this. So imagine you are, let's say you are long a call, okay? You are long a call, and you are delta hedge. The question to ask is, can I exercise this call, get rid of it, and replace it by something on the other side of the parity equation? And I would do that if and when, by doing that, it's actually cheaper than the call itself. Okay, so that's the argument. So it's actually a replacement argument. Is I think the best way to think about it. Okay, is I have a call. I already own a call, and I have delta hedged it, just like traders do. Okay, you might wonder why. Well, I already explained to you last time at the very beginning of the last session. So this is the context, okay? So you are long a call, you are delta hedged. For the reason for doing that, please refer to the starting remarks of Sunday's session. So you do that, and you are thinking, should I exercise the call, get rid of it, and recreate it, as it were, by doing all that stuff on the left-hand side? Okay? Now, you look at it that way, then you can see that in that example, if I remanufacture it, so in that example, the call is actually worth $20 if you exercise, okay? Whereas if you add up all the stuff on the left-hand side, you find that it is actually less than that amount. Okay, so therefore you would exercise. And in fact, the way you can think about that is once you exercise, then your call price is equal to S minus X, okay? And I just said to you, you would exercise if this specific condition was true. Now, if you exercise, you actually can take out the call and the S and the minus X because they are equal. So you would exercise actually if this here is true. In other words, if you rearrange, if this here was true. So you would exercise if there is a dividend coming through and the dividend actually exceeds the interest on the strike plus the put price. Ladies and gentlemen, in the end, that is the end result. And a lot of the questions that you get asked are based on these three very simple systematic observations. Okay? So I'll stop there for this, and like I said, I would like to come back to it perhaps on Sunday. Now, what I do want to do now, so this is purely a replacement argument, as I said, that the early exercise has to be considered in that context. Okay, should I get rid of the call and then remanufacture it? I think was the word I used somewhere. Should I remanufacture it or replace it or remanufacture it by putting together all those elements on the other side of the parity? Okay.